f of x is equal to x3 plus 3.
Kindly redo the last part.
What is the problem with the last part?
Finding the solution.
Of an inequality. Inequality. What we had was 4x, x minus 1 is less than 0. Said because it's a product, you equate 4x to 0 and you get x is equal to 0. You equate x minus 1 to 0 and you get x is equal to 1. And then you have 0 and 1 on a testing table. Get a number bigger than 1, a number less than 0, and a number in between. You want to see the sign of this product in these intervals. So we have 4x. We also have x minus 1. The product is f of x. You substitute here, you put -1, you get -4. Substitute here, put -1, you get -1 minus 1, which is -2. If you multiply these two signs, as you can see, it's a product, so we'll get positive for the function. If you take half here, you get +2. If you take half here, you get -half. If you multiply the 2, you get negative. If you take 2, you get 8, which is positive. 2 minus 1 is 1, which is positive. Positive times positive, you get positive. If you hear that a number is less than 0, all the numbers that are less than 0 on the number line are negative numbers. Just any slight movement to the left, you're in the negative direction. To the right, positive direction. So this is less than 0. So it's about a sign. So it is negative. So the solution set is going to be from 0 to 1, not including n of them, because it's strictly less. Do we have some more questions?
Do I add the sketch the graph?
Hello?
I'm asking for the board to sketch the graph.
I don't know if I can get that board. I'm unable to.
Sir, when do you add, like, let's say the 0 and the 1, like, when do you know when to add? In the solution set.
The solution said, when do
you add, like, you've seen the way you've said, you said strictly less than 0.
Mhm.
So I'm asking, when do you know when to put, like, the other bracket, the one that includes 0 and 1?
When it is less or equal to?
When it's less or equal to. Oh, okay.
This was the one that had sketch.
Yes, sir. I was asking about the -1/2, 0. Why did you use it to find, like, using this formula, the synthetic division? How did you get your x again?
Now we said that this point was given in the in the question, -0.5, when y is 0 in a point, it means that that point is on the x-axis. So it being on the x-axis, it means that it's an x-intercept. When you're getting the quadratic to 0, you're getting the x-intercepts. Now you already have one. So to look for the other, we could also choose to use what we had. That is by using static now, since we already had a fact.
So given any number in such a case, you just get the way it is, right? If it's equal to 0, if the y is equal to 0.
Yes, if the y is equal to 0, then it is sitting on the x-axis. Everything on the x-axis is the x-intercept. 0, n number is on the y-axis.
So,
You know?
can you please have a similar example? Another example.
You only need one example.
I haven't fully understood.
Well, the time goes on. Um, 6x squared plus 13x is greater than 5. This is a quadratic. So you take 5 the other side, so that you have 6x squared plus 13x minus 5 greater than 0. And then get the quadratic 6x squared plus 13x minus 5 equated to 0. You get back to the inequality. Excuse. So what's the product here?
-30.
-30.
-30. What are the factors? The sum is what? 13. So the factors?
15 and -2.
15 and -2. Okay. So let's use them. 6x squared minus 2x plus 15x minus 5 is 0. So we have 2x and 3x minus 1 plus 5. 3x minus 1 is 0. So 2x plus 5, 3x minus 1. So x is 1 over 3. X is -5 over 2. Then now we go back and do a table test. The number in between will be 0. 1 is bigger than that. -10 is less than -5 over 2. And then pick 2x plus 5. Pick 3x minus 1. And then pick, suppose we call it f of x or product. So just say p of x. If you take -10 here, you get a negative number. -10 here, negative number. When you multiply, you get positive. If you take 0, you have positive. 0 where there is x of negative, multiply, you get negative. If you take 1, you have positive. 1 of positive, then of positive. It's saying greater. So here, here. The solution set is equal to from negative infinity all the way up to negative 5/2 union 1/3 all the way up to infinity.
So just for clarity, when it's positive, then it's greater, right? And when it's negative, then it's less.
Yes. Number line as a 0, all the numbers with 0 are positive. The left of 0 are negative. So if you hear greater than 0, then we mean positive. Less than 0, we mean negative.
Excuse me, sir.
That's good.
On that stage where you equated the quadratic to 0, in the cases of where it's a fraction, are you also supposed to equate the fraction to 0 and then solve the denominator and the numerator separately?
Just solve the numerator and numerator separately. Don't equate to 0 for a fraction.
Okay.
Find A. If f of A is 28, find A. What does it mean? F of A is A power 3 plus 3 is equal to 28. So you take this the other side, you get A to the power 3 is equal to 25. This means that A is a cube root of 25. And then don't need to stress when there is nothing hard. Let's go to the roots now.
So can I say prepare screen? Thank you.
The roots of the equation 9x squared plus 6x plus 1 is equal to 0. Is equal to 4kx. And the roots of the equation are alpha and beta. 1. Show that the equation whose roots are 1 over alpha and 1 over beta is x squared plus 6x plus 9 is equal to 4kx. Show that. Another one is part 2, which says that find a set of values of k for which alpha and beta are real. We'll start with A. The quadratic has to be arranged first. 9x squared plus 6 minus 4k x plus 1 is 0. That's a standard quadratic equation. How did it become 6 minus 4k? You take the 4k to the left. Then because x is common, you factor it out. Then it remains 6 minus 4k.
Sir,
Hello?
so if we were given 4kx squared, would have done it with the 9, the one in front.
Yes. Because then there would have been something common. This means that in the question. So this means that since alpha and beta are the factors, if you add them, you must get negative b over a. If you multiply them, you must get c over a. This is a, this is b, this is c. So this means that alpha plus beta is giving us negative 6 minus 4k over 9, which is the same as 4k minus 6 over 9. And alpha beta is c over a, where c is 1, a is 9. So now we have two equations so far. I can write this here over 9. So we have this one. We also have this one. Now we know that the quadratic equation is x squared minus sum x plus product is equal to 0. The sum of the roots, product of the roots. Now show that the equation whose roots are 1 over alpha and 1 over beta. So I want to show that the equation whose roots, meaning the sum is going to be given by 1 over alpha plus 1 over beta, the product by 1 over alpha and 1 over beta. This is 1 over alpha beta. Well, for this one, it's not difficult. Alpha beta is known. So it is just 1 over 1 over 9, which is the same as 9. That's the product. What about the sum? We have alpha beta as a common denominator, and then beta on top plus alpha. So alpha plus beta is also known. We just got it here. So that is 4k minus 6 over 9. This whole thing divided by alpha beta which is 1/9. We can write this as 4k minus 6/9 multiplied by 9/1. This here 1, this there 1. So we get 4k minus
Sorry,
6.
sir. Where did that equation come from?
Which equation?
X squared minus 5x plus, I don't know if that is p
No,
equals to 0.
this is not 5, this is s. So we're saying that a quadratic equation, the general form of a quadratic equation is x squared. The general form of a quadratic is x squared minus sx plus p is equal to 0, where s is the sum of roots and p is the product of roots. So now, since we have the sum here, we also have the product of the equation whose roots are 1/alpha and 1/beta. So we can substitute. We get x squared minus the sum is 4k minus 6x, and the product is 9 is equal to 0. So we expand, we'll get x squared minus 4kx plus 6x plus 9 is equal to 0. If we take this the other side, then we're going to have x squared plus 6x plus 9 is equal to 4kx as required. We have gotten this one. We are told to show that this is indeed true.
Nice.
Sir,
Hello?
yes, I'm just confused on the second last step. Where did that x squared come from?
The quadratic always has x squared. If there's no x squared, then it's not a quadratic.
No, sir. Like, where did that equation come from?
The one in red,
No, the one, the last one, the second from last.
this one.
No, the one on top.
This.
Yes.
How do I explain? If you have ax squared plus bx plus c is equal to 0, you can choose to divide here throughout by a. And also on the right, you have x squared plus b over ax plus c over a is equal to 0. The sum of roots alpha plus beta is equal to negative b over a. So this alpha plus beta, if I say it is equal to s, we get negative b over a. If we divide by -1, divide by -1, we have negative s is equal to b over a. So that where there is b over a, I now put negative s. C over a, the product of alpha beta, is C over A. So this is the product. So I'd rather C over A, I put product. This is a general equation. Now we solved, we found S. We just found S to be, we found S to be 4K minus 6. We also solved, we found P to be 9. It is in this equation that we are substituting just S and P. X squared is already there in the quadratic. It's one that makes this equation to be called a quadratic. So we have x squared minus S. As we found it, we found 4K minus 6, x outside, plus P, 2 if 1, 9, is equal to 0. Then we expand, so we have x squared minus 4kx plus 6x plus 9 is 0. Take this to the other side. Then you have x squared plus 6x plus 9 is 4kx. Now find the set of values of k for which alpha and beta are real. For which expression? For the question, of course. Since this is part 2, it cannot talk about part 1 in this manner. It would have said find the set of values of k for which alpha and beta in 2 are real. Now, because it's just saying find the values of k for which alpha and beta are real, when you go back to the original question, you know that if alpha and beta are real, what is the expression? The expression is 9x squared plus 6x plus 1 is 4kx. We wrote this as 9x squared plus 6 minus 4k x plus 1 is 0. So this is A, this is B, this is C. The nature of the roots is determined by the discriminant, which is B squared minus 4AC. We say that if 1, D is equal to 0, then you have equal real roots. 2, if D is bigger than 0, then you have 2 real roots. 3, if D is less than 0, then we have 2 imaginary roots. Things that don't exist. They just exist in your mind. Imaginary. So we're told that question says that these two should be real. It did not say they are not equal or they are equal. So we'll go for a discriminant greater or equal to 0 because there's a real here, there's also a real in this part. This means that B squared minus 4AC should be greater or equal to 0. So what is B? 6 minus 4K squared minus 4A is 9, C is 1. This should be greater or equal to 0. As you can see, there's only K in here, so it becomes easy for us to solve. You expand, you get 36 minus 48K plus 16K squared, and then minus 36 is greater or equal to 0. Positive 36 and minus 36, we get 0. This implies that we have 16k squared minus 48k is greater or equal to 0. If we divide throughout by 16, we'll get k squared minus 16, that is 3, k greater or equal to 0. Then factor out k, which is common. You have k minus 3 is positive. So k is 0, k is 3. Then test. And pick 1 here, and pick 10 here, and pick -1 here. And then you have k of k minus 3 and the product. Negative, if you substitute -1 where there's k. Negative, if you add 2 negatives. Positive, if you multiply the 2 positive. Positive, if you take 1 where there's k. Negative, if you have 1 minus 3. And then negative. And then positive, if you take 10. Positive, and then positive. It's greater or equal to 0, so it's positive. The solution set is equal to negative infinity is never included up to 0. 0 we include because we have greater or equal to. Union 3 we include because the same greater or equal to all the way up to infinity. That is where ends. Next there's a question. Any questions?
Yes,
Okay, we meet tomorrow.
Thank you.